Okay, this one's real bare bones, no frills to it. We wanted to practice some more of the uglier ones where you got to do a little more moving stuff around. But this was our assignment. This was what we got through. What do you got? What we're going to get with the first half of chapter 6 here, it will specify in a lot of your homework problems, in daily quizzes, definitely on your test. It will specify by what method, because we have to know all methods for solving systems, because they each got their own purpose, and they're each used later in math. And the standard I am legally obligated to assess says students will solve by. Chapter 6. In fact, Monday the 25th. 3, yeah, 3 variable systems, 4 variable infinite systems. Ah! It really just depends on how good your numeracy is and if you slow down and write things. Yes? What was the entire goal of solving by substitution? If x or y is stuff, what do I do with stuff? So that was May 6. 2, 3, 4, 5, 6 days. 4 finals. Okay, we've also been getting kind of lax on some stuff. Remember that when the group has collectively decided a third of the class is not worth even attempting, we have lost all the privileges that are typically inherent to Sullivan's room. If I see a device, it is mine. That includes get your bags off the desk and stop trying to hide behind them. That includes headphones you think that I don't see. All of that goes away. We lost those privileges. I like that you're using the divider line. It works real good for folks.
When the Y is on this side, I don't know what to do.
Well, you've been working with me. I can do one thing and one thing only. It's amazing what a set of parentheses does to jog our memory. Remember, systems are, I got a couple of lines. Where will these lines cross? I know, shocking revelation. Your answer should be a coordinate, an X and a Y. Remember, don't just leave it as, I found X, I'm done. You're saying, if I were to graph these two things, this is where they'd land, this is where they'd cross. This is the one place in town that's got pizza and tacos. Okay? Does anyone need more time, or are we at the point where we got it, or we're just stuck? Speak now, or forever hold your pieces. Do it. Okay, it's pretty straightforward. If we just said, why is this stuff? Then replace y with stuff. I rewrite this as not 3x plus 2y, but 3x plus 2 something. That something used to be a y, but now we know y is stuff. So I replace y with stuff. That's it. Like, that is the big idea. Other than that, it's just do all the stuff you were doing first semester. Okay, I like that I saw a couple of you still bringing that old divider line. For some of us, that electric fence of doom helps us to not accidentally do too much to one side or the other. Step 1, plug things in. Step 2, disturb it. That's a 3x minus 2x plus 14 is 6. So here's what I mean about that divider line helping. Is some kids, I will still see this over and over, is they'll try to do this. Okay? We're so used to solving one variable equations where it's only one or two steps. You got to remember that equation is a balance. You just said add 2x. Add 2x again to that side. You put way too much on one side. But because they're on the same side, they are the same kind of critter. Okay, turtles with turtles, giraffes with giraffes. You can combine like terms. I can call that 1x plus 14 is 6. Subtract 14 from both sides. We called it the who's lonely game. You say who's all by themselves. He's lonely because he's lazy. You have to bring a number to him. 6 is all by itself. You got to bring a number over there. Otherwise, he'll be in his mom's basement trolling people on Reddit the rest of his life. You get x and a negative 8. But I can't just quit. I said x is this. Said the easiest way to put it is, if you have an x, you better find out why. X is this stuff, then I better put x into that stuff, and now I can find out the reason why. y is now a positive 8 plus 7 or 15. We said at the very, 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 very end of this, don't you quit on me. You have to write the coordinate. If I was going to graph these two lines, that's where they would have crossed. And for most of us, we probably don't make our graphs that big. So we wouldn't have seen that. We just would have seen two lines that were kind of headed in the same direction. You would have had to make the graph bigger. You would have had to change your scale. You would have had to go way off-road. And I've seen some of you try to draw lines to extend your graphs, and it's nasty. Okay? Substitution means I get to do this without graphing. So, stage one. It was already set up, y equals stuff. Did you plug it in? Did you use parentheses? Did you distribute correctly? Get the correct x, plug it back in to find the correct y. Do you actually have your coordinate? Okay. So it's kind of 4 for the process and 1 for the final answer. Did you plug it in? Did you distribute correctly? Did you perform your order of operations correctly? Did you combine like terms? All that kind of stuff to get to the final answer. Any questions about it? Because that's kind of where we're picking up today, is we could have rushed through the end of it. But we have time, so I didn't want to. But do we have questions from the homework? It was really small. I think I only had, 4 problems or something? It was just practice this when it's not bad. Okay? Then, so that was kind of 2, and said I was not happy with this book that their examples had such nasty answers. Like, the first example that you get should not be tougher than anything I would put on a test. That's just mean. That's like your first day of football practice and they put you up against the senior linemen. They just pummel you into the ground. Although they kind of do that to freshmen anyway, just to say, hey, welcome to the team. See like 3 of you going, yep. Dave Nash used to grab us by the helmets and he'd lead us around like puppies on a leash. You'd have to like dog crawl after him. I actually want to bypass 4 here. And I want to do 1 more of these before doing 4. I want it to be one that comes out clean though. So 2, 2, 2, 1, 1, negative 1, cancel. Nope, can't do that one. 2, 5, 3, 1, 3, x stuff. 5, 5. There we go. That guy. Number 4. See, where we left off was what happens when these aren't set up to easily be moved around, to easily substitute. We have to get something by itself. One of the x's or one of the y's. I need to say x equals junk or y equals junk. So right now, what do you think, like before you just go for it, what do you think is the easiest to get by itself, preferably that won't result in a bunch of fractions? The x on top, right? I just add 2y over, we're good to go. Some of us were so ingrained with y equals mx plus b. Some of us would have said, I'll do this. But now you have 1/3 x plus 4/3, and we all know how much you love fractions. We probably don't want to do that if we can avoid it. So, just like Ava said, I'll take this guy over here, x minus 2y is negative 1. Let's add 2y to both sides. Again, if you need that divider line going all the way back to our safety net from first semester, show the 0. Remember, when I say negative 2y plus 2y, don't just leave it. You put that big honkin' 0 on there, what it usually will do is if there's a sign or a coefficient, say these were swapped in order, it'll keep the sign of x with x. So, now we have x is 2y minus 1. Don't try to combine those. They're different kind of terms. They are not like terms. 2y's minus 1 is not magically 1y. That's a turtle and a giraffe. Okay? Not the same kind of critter. What was the other rule that we said for when we're plugging things into places? Always use parentheses. Can I take x equals this stuff and put it right here? Don't plug it back into itself. Because if you ever plug an equation back into itself, you will get the identity. That would be, Preston! What's your name? Okay. The input is the output. Identity. Right? I hope you're not that confused. Okay. So if x is this stuff, I will replace x with stuff. I'm going to say 3y is stuff plus 4. Stuff is now 2y minus 1. So, combine like terms if you can. That's 3y is 2y minus 1 plus 4. If you didn't need to write that line, you don't have to. But for some of us, being able to see all of our terms, I use those boxes an awful lot in my inclusion algebra class because that is what makes sense for us. Okay, I have 3y is 2y plus 3. And you play the who's lonely game. You say, who's all by themselves? So sad. 3y is lonely because he's lazy. You need to bring the date to him. Don't bring him a canoe. Don't bring him a teddy bear. Don't bring him the latest copy of StarCraft 3's expansion. That's going to make him stay in his mom's basement forever. You bring him another person. Bring another y over to the y. You want like terms. And it turns out I don't have to divide at the end of this because y just is 3. You're not done yet. Just because you found a thing doesn't mean you're done. I have to have a coordinate. We said, well, you get a choice. Where do you want to put that? I could say, put it in this equation. I could put it in this equation. I could put it in this equation, assuming that I did my work correctly. I'd probably do the third one and hope that I did my work correctly. Because it's easier, that's almost direct variation, where I'm just going to dump a number in and be good. So I'll say x is 2 by a thing minus 1. The thing is 3. Yellow? Yellow. So along the way, step 1. You got to get something by itself to do substitution. Step 2. You plug it in and solve. Step 3, you go back and solve for whatever the thing was that you plugged in. 1, 2, 3. Make sure you finish off the problem by actually stating x comma y. Don't get caught in little traps. Some kids will put 3 comma 5 just because that's the order that they found them in, so they think x then y, first then second. No, x, y, 5, 3, not 3, 5. Okay. So some of these are related to number 4 here. Go back right before example 4. I'm pretty sure you didn't take up this whole space, right? You got a little room? Got room for a problem? Maybe. The big writer's cringe?
Yes.
Okay. Find a spot somewhere. I just want to, we're going to throw something at you. I'm just going to pick numbers. I don't know how it's going to work. I just came up with stuff. Just find a spot. Okay. We are going to do problem 4. We are going to do those 3 problems. But can you find a spot, a corner, a previous blank page, a margin, hell, piece of scrap paper? I don't care. I just want to get some more practice in. And the trick to these was you are a lion stalking the herd. You don't go after the big alpha. What up there is the easiest to get by itself?
So this first problem, should I put it into y even though there's a y right there?
No, you need to get y is stuff or x is stuff. You got to rearrange one of these before you can go plugging anything into places. Okay. Typically, the easiest one to get by itself is something that has a 1 or a -1 as a coefficient, meaning no number in front of it. Use your parentheses and you should see.
So that would be plus 48. You got 12.
Mm-hmm.
So
Yeah, plus. Yep, you're right. I don't know what these answers are going to come out as. Twelve, 48, 48, 75, 53, 12, 24, -21, -21, or 50. Ew.
That's what I'm saying.
Okay, yeah, they ain't pretty. I hope you got a calculator or you know your fractions. They ain't pretty. That's kind of where we went sideways last time. Remember, there are calculators over here. Alpha y equals brings up your fraction menu.
Right idea.
Right idea? Okay. And no, you can't replace 3 with that. If you said y is this stuff, then replace just y with that stuff.
So did I do it?
You do 5x minus 12. It's not y anymore. It's this stuff equals 3. You said y is this junk. So replace y with this junk. And then solve like it's first semester again.
Thank you.
Mm-hmm.
So since we're solving for like y, should we do the 12 like with respect to the 5?
I would use this guy because he's got a coefficient of 1. 1s are easy to work with.
Oh, so like
Just, yep.
that equals and then add it back.
So we won't use this yet.
Oh,
We'll say, how do I get this y by itself?
you subtract it by
Okay.
both.
And if you need this, right? For some of us, that line is the saving grace. Show your 0. We got a y. Are these the same kind of animal? No. So they just stand next to each other awkwardly. Okay. You just said, y is this stuff? So 5x minus 12, it ain't y anymore. It's stuff.
And then that's when you put that in there.
And then you put this, because this is y. So we'll put that stuff in place of y. You are substituting.
And then you do this line thing.
And then you solve that guy. Okay, it's a substitution. Yeah, they ain't pretty. It was like something over 53 was the first one I got.
That.
Ew. Yeah, that's gross. I got something over 53 to begin with, and then you and Keely go compare notes because you both got the same denominators, but one of you went sideways. And now we got a third option. Okay, fractions are evil. Do we got the calculator that's going to do the fractions for us? Because I've seen 3 different answers now. We've all got the same over 53. That's good. We have to be able to work with fractions. Math is not always pretty.
What? No. It's 3 minus 24.
Go and put some of your secant, cosecant graphs up here and scare the bejesus out of them. Okay, so I'll run through it. I want you to have your calculator on hand, and let's make sure that we did it correctly. Step 1. What is the easiest to get by itself? The least amount of effort is anything that's got a 1 or a -1 for a coefficient. Because then you won't have to divide, which means you won't have fractions. So the first thing I'll do is this guy, subtract 4x. I'm not touching this equation yet. I don't have to worry about that one yet. I'm just working with this. Zero it out and say y is -4x minus 2, and I will just leave them standing awkwardly next to each other because they are not the same kind of critter. Can't mate a turtle with a giraffe. Fun to watch, doesn't accomplish anything. They just stand there next to each other looking awkward. Now, if I've said y is this stuff, I should now be able to say 5x minus 12, it ain't y anymore. If y is this stuff, replace y with stuff. Are we cool with that? Get x or y by itself, plug it into the other equation. Okay, now, Aiden, you were asking, do I multiply by 12 or -12? What did you come up with? Okay. Remember, every time we run into a plus or a minus, it's a new term. Oh, well, my shirt touched it. One of the perils of eating your feelings is sometimes your gut hangs over this. We have big yellow. There we go. If I put those little divider lines in between every time I see a plus or a minus, that's what tells me it's a negative 12 smashed up on there. And I know that I'll distribute because there's no space in between there. Remember, if anything is smashed together, like rabbits and hormonal teenagers, they multiply. Any of you go to prom? No? Okay. So, negative 12 times a negative 4x is positive 48x. Negative 12 times a negative 2 is a positive 24 equals 3. So who already sees, uh-oh, yep, that was it. The smirk on your face when your neighbor does anything wrong. Oh, you're pointing at Aiden. Okay, I thought you were pointing at Keely. She's just gonna deck you one of these days.
Sullivan's just gonna watch.
I turned around, I grabbed something out of my fridge, and there was this scream. Every time that I see a bunch of terms on one side, I want to see if I should distribute something. Can I combine anything? In this case, yeah, I can. 5x's and 48x's is 53x's. Plus 24 is 3. You play the Who's Lonely game? 3's over there all by himself. So I zero this out. I got 53x's left. 3 minus 24 is a negative 21. Negative 21 divided by 53 stays but ugly. X is negative 21 over 53, which I think is what Grace had. Okay. Okay. So, well, that was just the last one I saw in short-term memory go, wee! I have X. Find out why. Otherwise, you're going to end up with more of them. Y is negative 4 by thing minus 2. If you don't know how to multiply that out, if you don't want to fraction, yo, grab a calculator and make it do the hard work for you. Say negative 4 parenthesis, just like it's written. Alpha y equals is a shortcut menu on these calculators you have access to here in class. And I put in a negative 21, arrow down, 53, arrow over, close my parenthesis, minus 2. I type it exactly like it's written. That's what's called a right view calculator. I can type it the way I write it. Hit enter and it'll simplify it for you and everything. Negative 22 53rds. And now Grace over there like, mic drop. Okay, so we got to our final answer. Make sure you put it as a coordinate. Negative 21 53rds, negative 22 53rds. Gotta make sure I put that parenthesis there. People are gonna be getting mean. We're at, what, 13 out of 15?
Should I be double checking your work?
Quiet, freshman.
That means I get their brownies too, and I get points for them. That's definitely how that works.
You would have to negotiate with the team. So, that process. What happens if I do that process and it goes awry? There was something that we ran across first semester where we did all the math right and we got waffles equals penguin. We got 5 equals 2. 0 equals negative 8. Do you remember what that was? No solution. What if I get 5 equals 5? Okay, now first semester it was infinitely many solutions. Or sorry, it was all real numbers. Now, because I'm talking about lines, if I get 5 equals 5, I can't say all real numbers, I say infinitely many, because these are systems. So that's what these are. They're going to give you some system, you go to solve it, and something weird's going to happen at the end of it. So they already told me X is stuff. If X is this stuff, I better replace X with this stuff. 3.5 something plus 7y is 14. That something is negative 2y plus 4. X is stuff, replace X with stuff. Then solve it like you're back in first semester. 3.5 times this stuff is a negative. Oh, I'm done doing your mental math for you. Nope. Defense. Defense. It is negative 7y. 3.5 by 4. Positive or negative? Okay. And then this positive 7y is just hanging out over here. And I go to start combining terms. And on the left-hand side here, negative 7y's plus 7y's is no more y's. I get 14 is 14. We say, hey, Aiden, what's your name? Identity, right? Input is output. Billy Bob is Billy Bob. 14 is 14. Waffle is waffle. You want to go further? You can turn every one of these identity style problems into 0 equals 0 at the end of it. Or x equals x. 5 equals 5. 14 equals 14. I get down to that final answer, and I'm going to call it, not all real numbers, infinitely many solutions. Infinitely many solutions. That means these two are the same line. If I were to solve for x, if I subtracted 7y divided both by 3.5, it would get another negative 2y plus 14. They're the same, or 4. They're the exact same thing. So by process of elimination, actually that's next week, this one's probably going to end up the other way. Who's the easiest to get by themselves? Could I get this by itself as well? That's something you'll see in geometry. There's the substitution property and the transitive property, where if I were to rearrange this and say y is 3x minus 13, y is 3x minus 11, set them equal to each other. Okay, you'll see that again in geometry. See, in geometry, you don't have to just do math, you prove math. You have to prove why it's true. Prove that these angles are congruent. You'd say, well, look at it. They're the same. I can even trace it. And they say, too bad. You have to give me statement, reason, statement, reason, statement, reason. It has to follow a logical proof. Proofs are awesome. Okay. Yeah, y'all also didn't do flow proofs.
No, we had no idea.
Oh, they're so much better. Anyway, if y is stuff, I will replace y with stuff. So I have stuff minus 3x is negative 13. In goes 3x minus 11. I don't have anything to really monkey with here, so the parentheses are unnecessary. 3x minus 3x, that gone. I get negative 11 is negative 13. Okay. Donkey does not equal fighter jet. So since they're not the same thing, you're going to call this no solution. Or you can use a symbol for empty set because the set of solution answers is empty. It's your choice. Okay? So solve them the same way you've been solving them. Only difference is you might end up with something weird. Go. Oh, maybe you do got to do a little bit of work. See, none of the x's or y's has a coefficient of 1. So now you have to choose. Do you want to get x by itself or y by itself? Top equation or bottom equation? Going by substitution, there are 4 different ways to start this problem, and they are all correct. Just pick something. Just pick the x or the y, top or bottom, and say, I'm going to get that by itself. Start moving things around. That one's gone, that one's gone. Brennan's here. Peyton's here. Is there one else, right? Yeah. Okay. Well, good job. You got them open on your own. Good job, buddy. My kid fights with his all the time. Such a big job. Big boy job. Good boy job. What you got? Okay. Oh, you can't go starting to do any of this yet until you have something by itself. You don't have anything by itself yet.
So like here.
See, here I moved some stuff. X equals this junk. Y equals this junk. You don't have X equals stuff or Y equals stuff yet. You have to make them equal. So you just pick one of them and say, I don't do that one. Okay, maybe I'll tell you what, you'll actually end up with no decimals or, well, now you can have fraction no matter what. Get this X by itself. That's probably going to be the easier one.
Alright.
Okay,
This one?
get that X by itself. Change this equation so that at the end it just says X equals stuff.
Oh.
And then once x equals stuff, now you can replace that. I'm curious what kids chose. Who got top y by itself? One potato? Top x by itself? No one? Bottom x by itself? Two of us? Three? Bottom y? One? So kind of a mix, kind of a mishmash. So I'm just gonna wing it, and we will listen to the dice gods. And the dice gods will say 1, 2, 3, 4, just so you know that I'm not cheating. 4 it is. I will get this y by itself, because that is what the dice gods have dictated. So if I have 2.5x plus 3y is 4, and I want that by itself, I start by subtracting 2.5x from both sides. So I have 3y is, what is 2.5 as a fraction? Okay. Now the reason I do that is because when I divide by 3, remember, dividing by fractions is easy as pi, flip the second and multiply. Dividing by 3 is the same as multiplying by a third. So if I take this whole honkin' thing times a third of 3y is just y. A third of negative 5 halves x is negative 5 sixths x. A third of 4 is 4 thirds. Be not afraid of the fraction. I just said y is stuff. So where am I putting it? Top equation or bottom?
Top.
Why?
For fun? I don't know.
I can't put this into here because that's what equation it is. Don't put an equation back into itself, or you will get the identity every single time. I'm gonna put it right here. That's not 6y anymore. Now that's 6 this junk. Now some of us might be afraid of fractions like that, but it turns out that when I distribute, they clean themselves up. 6 is canceled. 3 and 6 becomes 2 and 1. 2 by 4 is 8. Combine like terms, negative 5x plus 5x cancels, and I get 8 equals 8. So, what's my answer? Infinitely many solutions. Let's go back to what we were doing with our graphs. Do you remember your words? Is this consistent and independent, consistent and dependent, inconsistent? Go back to section 6.1. You had a nice little chart where it showed you 2 lines crossing, 2 lines parallel, the same line, and it told you what each of those were in vocabulary terms. It is consistent because there's a solution. Yes, first hour is in that pile. It's consistent because there's a solution. Will it be independent or dependent? Dependent because they depend on each other. They're the same line. Okay, so that vocabulary, you'll use it off and on throughout the next couple of years. I'll tell you the part that really matters is that. You'll use both, but Infinite solutions is the part that really matters. Well, we have to write both now. Well, unless I have it in the directions, in which case, on the review, when I say, hey, remember this in section 6.1, that'd be the point where you write that down. So, okay, so this is just more of the same, and then words. And then Satan said, let there be words with math. If you remember, there was a page, and I said this would be really handy to have written as a note card or something so you don't have to keep flipping back and forth. There was a page where we wrote out our 3 different forms of linear equations. We have slope-intercept, point-slope, standard. Let's see if you remember who's who. Slope-intercept form, what's it look like? That's the one that's pounded into our brains. You go and ask your parents, what is algebra? That might be one of the few things they remember. It's just that important. But next to it, we wrote out in words how this normally looks in a word problem. Do you remember? Okay, in terms of graphing, I like that. Rise. There you go. Run x plus, and then this was the coordinate 0b. Okay. If I wanted the words, though, yep. Y equals rate x plus start. That's typically what we're going to see. So when they tell me it costs $20 to get into the amusement park and then $2.50 per ride. Well, they told me how much I started with. They told me what my rate was. So y equals 250x plus 20. Point slope. What does that look like? There you go. Maybe it's important to put next to these that this and this will be numbers. That this, and this will be numbers. You always have the y and the x there in the equation because that's how I get my input and output. But those will be numbers. Specifically, as a word problem, y minus our output is rate x minus my input. And then standard, we're going to see these more with our next section, 6.3. ax plus by equals c. A, b, and c don't have to be integers, but that's usually the way that the book wanted us to write it. I can say 3.5x minus pi over 7y equals 2 squared root of 5. That's still in standard form. It's just butt ugly. In terms of word problems, we had a rate for the first thing, x, a rate for the second thing, and a total. Instead, if you have this on a sticky noted sheet in your notebook, you have this on a note card, you are going to use these 3 equation forms, these 3 word problem conversions for the rest of high school. I'm not even joking. You are going to use this a lot. Okay, it's just one of those things you should know. Okay, you go, by the time you're a junior, say the back half of your junior year, beginning of your senior year, you go to take your ACT. By that point, maybe you've gone on far enough. You've been through Algebra 2, maybe all the way up to pre-calc. Okay, maybe instead of pre-calc, you decided to dip down a little bit and do college algebra. when you go take that ACT, I'd say a third of the questions are just based off of a linear equation. Do you know the context of a rate and what inputs and outputs and totals and starting points are? So, y'all got it. I hope. All right, let's look at the words that they have for us. No, not you. There we go. Snack bar sells 2 sizes of snack packs. Num num. A large is $5. A small is $3. That was 2 rates. Sounds an awful lot like what? Standard form, 2 different rates. In one day, they sold 60 snack packs for a total of $220. So it's right there in the problem. They said something, something total. I go and look at my 3 forms and which of them has total? Standard form. So write it. Before I go writing it, I should probably say, what the crap am I talking about here? Next to every one of these problems, don't just start throwing down X's and Y's and hope that someone figures it out. Tell me, what are the 2 things we're talking about? Okay, money and packs. What's another way we could do it? Large pack, small pack. Uh-oh. So which is it? Okay, and this is where I want you to put a little side note next to this, because we're going to see this a lot, is that the question tells me my variables. The question tells me my X and Y, tells me my variables. How many small snack packs did they sell? So they want to know how many small packs. So that means the 2 things I'm talking about must be the small packs and the large packs. They didn't say how many total packs. They didn't say how much total money, because that was given to us. Okay, so large packs, small packs. Set up an equation. Pink. We said we saw totals, right? Look in the problem. Didn't they give us 2 different totals? Okay. The 2 totals are also going to tell me what goes in which equation. Since this is a total in money, then the stuff in this problem has to be about money. The total was in money, so the rates should be in money. So $5 for this kind, $3 for that kind. The other total was what? 60 what? Packs, snack packs. So there's no rate for like twice as many of this kind than that kind. So I just say the 2 kinds of packs I'm selling are large and small. Large ones plus small ones equals 60 total. $5 for large ones, $3 for small ones is $220. But notice that this was dollars, this was dollars, this was dollars. The total was dollars, so the rates that go with it have to be dollars. This is about money, those better be about money. This was about packs, those better be about just packs. And now, off to the races we go. You want to get X or Y, top or bottom, by itself. Okay, I heard bottom Y, I heard bottom X. Is anyone up for either of the top ones? I see a couple of you shaking your head, a couple of you making this ew face. It would be longer to deal with the top equation because they don't have coefficients of 1. Use coefficients of 1 if you can. So right here, I'm just gonna, I'll subtract y and get x is 60 minus y. So if I just said x is stuff, I'm going to go replace x with stuff. So that's 5 times a thing plus 3y is 200, 200, 220. I just said x is this junk. I replace x with this junk. 60 minus y. Solve time. 5 times 60. 3 hondo. 5 times a negative y is minus 5y. Some of us are dying without that line there. Can I combine any terms on the left? Any of them? Negative 5 plus 3 is what? Not you. Play the who's lonely game. Who's all by themselves. Bring the date to him. Say, hey Steve, I got a friend I need you to meet. We're worried about you, bud. Okay. Zero's out. I got negative 2y is negative 80. Divide, and finally, got y is 40. Now, thankfully, I got a real easy place to put that. Should I put y equals 40 into this, this, or this? Right? If I just jam 40 in there, 60 minus 40, I'm done. Make sure that you answer the question. Don't just leave it. Actually answer the question. How many small snack packs did the snack bar sell? If you didn't back here actually write that out. Oh, wait a second. Could I have just skipped that last step because I already knew? Okay. 40 small snack packs. They still make those? Snack packs, the little pudding cups? No? Yeah, maybe? No. They,
Like in like a little bowl thing with like a lid on it.
it's just a tiny little pudding cup. There's a little foil lid on it. They still make those? Okay. I'm just curious.
Oh, I got it.
My wife is adamant that she has to make her own pudding, so I don't know. Okay, try it again. Tell you this one's set up the same way. 2 standard equations.
Could we just put new games and old games? Could either of them be X and Y?
Yes,
Okay.
that's why we have to label them. Because what if you call new then old and someone else says old then new? Right? You solve for X first, they solve for Y first, but you both get the same answer and now you're confused. If you label them, it should prevent that. Always label first. You set it up the same way. Rate x plus rate y equals total. And I'll even tell you the second one is just x plus y equals total. Set up the exact same way. Make sure you have the same equations as your neighbor before moving on to the actual solving process. Found out I was unfairly judging first hour and second. Y'all ain't slower than my other semesters. I was saying about the testing. I got faster.
Oh, really?
Started ADHD med second semester.
Oh.
You're not 30% slower. I'm 25% faster.
Does that mean I'm still a
No, it just means I need to adjust my time. I need to go times 8 for your tests. Which means I have to start doing times 10 for Algebra 2, and 12 for Algebra 1. God, it's going to change everything.
Because if you get stuck on one problem,
Yeah.
you're basically out of time.
Yep. Let's make sure we have the right equation before anything else. The first thing that I would do is off to the side, I would say what's what. What are the two things we're talking about? Oh, go to the question at the end. How many new games did you rent? Okay, so what's the thing that goes against new games? What are the two things? New games and old games. Okay, so how do you want to set it up? New then old then new? New, old, okay. New games, old games. Okay. Set up your equation. Your equation is based off of, in here, they gave me some totals. I pay 22 bucks. That's a total. So I'm going to have so many y, so many x. And because that's $22, the rates that go with them are more dollars. 4 for the new stuff and 2 for the old stuff. The second equation, remember, they also said we rented 6 games. That means the total of new games plus old games was 6 games. Could have been 1, 5, 2, 4, 3, 3, 4, 2, 5, 1. Heck, it could have been 6 of one and none of the other. Or could it? Could I have done 6 of only new? Why not? Okay, 6 times 4 is 24. That's not going to get me my right total. Could I have done only 6 old ones? 2 by 6. No, that's not enough money. I must have had some new games in there. So, next up, who do you want to get by itself? X or Y, top or bottom? Okay. Minus X, minus X. 0 out. Y is negative X plus 6. And then Y is stuff. Replace Y with stuff. If you just said 4x plus 2y is 22, but then you found out what y was, now it's 4x plus 2 of these. Go ahead and solve like you're back in first semester. Put your little line of doom there. Take positive 2 times negative x. Positive 2 times positive 6. That's algebra 1. This is half. They haven't even got to FOIL yet. Nope. And be sure that we'll actually teach them what the letters mean.
That'd be good.
Right?
Very good.
Any of those on the left side go together? 4x's minus 2x's is 2x's. Play the Who's Lonely game. 22 all by himself. So bring him a 12. 2x is 10. Divide both by 2. I'm writing out every step, even though you don't have to. If you can do it faster than that, but I'm going to write every step because some of us, well, first semester didn't go so hot. So maybe we need to see every one of these steps. At algebra half, algebra 1, I'll usually say write them out. Once you get to algebra 2, I don't care. If you don't write the steps and you screw up, that's your fault. If you don't write the steps and you screw up, that's your fault.
These.
Oh, cool. Are you all done with them?
Hang on, no.
Okay.
Are you all done with these?
So anyway, I say y is stuff. I'll plug in stuff. That's a 6.
We just made them charge.
Oh, okay. Set them over here and I'll charge them over the weekend for you. Okay, just somewhere over there by the Death Star.
Okay, what about right here?
That works too.
Okay.
All right. Make sure that when you get to the end, you actually write out as a coordinate, though. It was 5, 1. So what does it mean? How many new games did you sell?
5.
Or rent? 5. Okay. Which is kind of the end of the road. Can you translate words into math and then do the math? Okay. I know that you can, I think you can do the math. But words into math is hard. And we do have time. So what I want to do for these 3, I don't want you to solve them. I just want you to see if you can write the equations. Okay? Don't bother solving them. Don't worry about that. That comes later. That's the assignment. I want to see, can you write the words into the math? Well, no, we're going to have an assignment. I'm saying right now. Don't worry about solving these. Just translate them. Okay? I'm being time efficient.
Where would the second C total be?
They're both in terms of it. That's how you find perimeter, right? The longest side is shortest side. And then the middle side. So maybe instead of this, I write longest side, shortest side, middle side. Like that. And now is means equals. Longest side is
4 inches.
longer than the shortest side. Do you remember what then did?
It goes on the end.
At the end, right? So 4 longer than the shortest side. The shortest side is
3/4.
the length of the middle side. So the shortest side is 3/4 the length of the middle side through 3/4 times the middle. So you chain them. Replace the S with the stuff. Replace the S with the stuff. Now you have L is stuff. Replace the L with the stuff. You substitute into substitute. It's kind of like those Russian nesting dolls. You know, it opens up and the little guy comes out, and he opens up and the little guy comes out. You got to chain them together. Put this stuff into there and that stuff into here. Wow, this did come out of an old book. Wasn't this year's Super Bowl like 54 or something? It's 50 something.
So it's basically y equals of x plus b. Like here are these.
Mm-hmm.
And
So you replace that guy with this stuff. Replace that guy with this stuff. Double replacement. Remember the words is, am, was, were, are linking verbs? Those are the things that mean equal signs in math. And I'm not going to lie, these are tough. If I just threw this at you right now without going through them ever before, I would be surprised if more than 2 people in the room could do any one of them. They're tough. Okay, when you're first learning word problems, that's tough. Step 1, go to the question at the end. The question at the end will determine your variables. The NFC won 2 more. How many games did each conference win? So that tells me the 2 things I'm talking about are what? The 2 conferences. How many games that each conference won? The 2 conferences are AFC and NFC. How about instead of X and Y, I just put A and N? American versus National. National's better, by the way. So those are the 2 things I'm talking about. They want to know how many did each conference win. All right. That gets rid of this. Go back through anything else. Did they give me a rate? Did they give me a total? Did they give me, in this year, that many? An input-output. What do I have? We have 38 Super Bowl games. That's a total. So I know that 38 total games is all of the AFC wins plus all of the NFC wins. And it will total 38 games because none of them have ever tied. Go find a different sentence in there. Preferably one with numbers in it. NFC won 2 more games then. NFC won, it's a linking verb. 1, let's try that again. The NFC 1, so NFC is 2 games more than. What did we do with that all first semester? More than. If it has the is or are stapled next to it, if it says is more than, that's Pac-Man. This is just plain old more than. If I say Preston is 7 inches more than Killian. At the end. So 2 more than says plus 2 onto a thing. NFC 1, 2 more than AFC. You're ready to go for substitution, right? N is this stuff. Replace N with this stuff. Okay. The percent solution ones. They crop up an awful lot in Algebra Half, Algebra 1. You'll see them again in chemistry. These ones are sticky. You make 100 gallons of 18% solution by mixing this and this. How many gallons of each are needed? What they gave you was how many gallons of each thing. So I've got 2 things. I have my 18% solution. I have my 12% solution. And the sucky part about that is it's the label, but it's also the rate. These ones are tough because it's the label and it's the rate. Because if I take 18% of this stuff and 12% of this stuff all together, oh wait, you're making an 18. Oh, someone could have caught it. Someone could have caught it. You're mixing a 12 with a 20. There we go. Whew. Reading the problem explains the problem. You have 12% of this stuff, 20% of that stuff, all together is making 18% of. If I take 12% of this many gallons and 20% of that many gallons, I'll get 18% at how many gallons? 100. But that also is my other equation that I'm making 100 gallons of something. X gallons of this, Y gallons of that is 100 gallons. Okay. Those solution problems, you'll also see them, they're just called mixture problems. You'll see ones like that that ask about cashews are so much a pound, peanuts are so much a pound. How can I make a mixture of 5 pounds of mixed nuts that cost this much total? They'll use this rate, and it sucks. The perimeter one, Grace, you were working on that one. If I got a triangle, I know that I've got the shortest side, the middle side, and the longest side. What do I do to them to make a perimeter? Add them all up. So I know perimeter is small plus medium plus large. They just said the perimeter is 24 inches. Cool. I can replace that. That's my first sentence. Look at the rest of it, and they keep using the word is. They keep using that linking verb. Longest side is. They're giving me equations. Longest side is for longer than, so I'll add 4 onto shortest side. Then they give me shortest side is, S is 3/4 the middle. So take 3/4 times the middle. You get double substitution. I'll put this stuff right here and right here. And then once I find out what this is, I'll put all of that right here. I'll get one big honking equation that's all a bunch of m's. I think you're okay with the mechanics of substitution. It's words. Now y'all got a big long weekend up here. We got four-day weekend and then Tuesday, and you're not back in here until Wednesday. That's a lot of time. There's no reason we should be coming in on Wednesday having not done this, having not asked a question. Well, what's 5 by 24? Plus another 22.5. 142.5 hours. You got plenty of time to get it done. I kind of got a sketch calendar up on the back. You guys are blue. We will have our quiz, I think a couple were asking, on Tuesday the 26th will be our next one. After that, it's kind of hit and miss what we're going to do because we're actually going to finish the chapter 2 weeks early. I don't know what to do with those last 2 weeks. So,